Hey guys, Mr. Isley here. We're going to be beginning our last chapter of the year, which is chapter 9B. It's the second half of chapter 9, and it's all about solving quadratic equations. And we learned a little bit about this way back in chapter 7 about when we could factor things down and then we could solve them by setting them each equal to 0 each factor using the zero product property. But that's not the only way you can solve quadratic equations. And it actually, if that polynomial you end up with, that quadratic equation, isn't factorable, there are some other ways that still allow you to obtain those answers. And so that's what we're going to be working on. There's 3 sections to this chapter that we're going to go through. So these will be 3 different lessons. They're fairly short, pretty simple, and I think you guys are going to do really well with this. So let's get started with this first section of notes. So before we really jump into it, I want to address 3 terms that you're going to hear throughout this chapter. The first one is known as what is called completing the square. And as you can see on your paper, this is a process that creates a perfect square trinomial. Now remember, perfect square trinomials are polynomials that can be factored where they really only have one factor that's being squared by itself. So that would be like, it would look something along the lines of like x plus 2 squared, which means the same thing as x plus 2, x plus 2. So this process helps us get this perfect square trinomial, and we do it by adding a constant c to the expression x squared plus bx. And we're not going to deal with this today specifically, but this is one of the processes that we're going to learn about today on how we can take an unfactorable, or not today, in this chapter. We're going to learn about how we can take an unfactorable polynomial and create a perfect square trinomial through completing the square, and then be able to factor in and solve for real solutions. The second term you're going to hear is quadratic formula, and this is just simply a formula that gives solutions of any quadratic equation in standard form. So you can use this formula whether it's factorable or not factorable. Any quadratic equation that goes in standard form, and remember, standard form is ax squared plus bx plus c. That's standard form. But any one of these, you can use this information to solve, use the quadratic formula to solve it and come up with the solutions. Now, the quadratic formula we'll spend more time on in a later lesson, but just so you're aware of what it is it's x equals negative b plus or minus the square root of b squared minus 4 times a times c, and then that's all over, that entire thing I just said is all over 2 times a. So what we do with the quadratic formula is this formula is going to look the exact same. So we're going to take anything that's in standard form, and we're going to take whatever's in the placeholder of that letter, and we're going to substitute it into the appropriate spots with its sign in front. And so this allows us to solve quadratic equations that aren't factorable. It allows us to solve ones that are. It's just a formula that's derived from actually taking this ax squared plus bx plus c equals 0 and solving for x. We're not going to go through that entire process because it's just really more important that you understand what the quadratic formula is. And then the last thing we're going to talk about is the discriminant. And the discriminant is used to determine the number of real solutions. So real numbers, all right, of a quadratic equation. And the discriminant is really just what's underneath this square root right here. We can plug information into that portion and find out if there's going to be 1, 2, or no real solutions to this. So discriminant deals with b squared minus 4ac. We would just plug that information in, and then if it is greater than 0, less than 0, or equal to 0, that'd be correct. Then we can determine how many solutions that there are in that. So we're able to use that information. But those three terms we're actually going to revisit later. Today is all about solving quadratic equations using square roots. And we just spent a lot of times on square roots specifically in that radical section. You've learned about them in previous chapters, previous years of math. And so what this allows us to do is we can take square roots of equations that are in the form of x squared equals d. All right, so that's written right there on that little chart. So x squared equals d. So when d is greater than 0, that means there's two real solutions. When d is equal to 0, that means there is only one real solution. And when d is less than 0, that means there are no solutions. No real solutions, I should say. And the reason we can figure these things out, and one of the big things you have to remember with square roots, we really only dealt with the positive answer on the square root. We talked a little bit earlier in the year about how square roots actually have both a positive and a negative answer. Because if you took, if you had a positive 4, you could multiply negative 2 times itself and still come up with a positive 4, or you could multiply positive 2 by itself and still come up with a positive 4. So big thing we have to remember is that all of our answers are going to end up, like it says right there, x equals plus or minus the square root of d. So we're going to have a positive version of that number and a negative version of that number. So how to solve using square roots. That's what we're going to talk about, and that's what we're going to do on our examples today. How we solve using square roots. The first thing we need to do is get the equation through addition or subtraction, if needed, into ax squared equals d. Now, it may already be there, all right? It may already be there. But if it is not, you may have to subtract the d across or add the d across, but we need to get that number equal to ax squared. If a is not a perfect square, so it's not like 1, 4, 9, one of those numbers that we can easily take a square root of, then we're going to divide it across. And we could still even divide it across even if it is a perfect square. Typically what we're going to do is we're going to divide a across. So we're going to divide it on one side, which means, as we've always talked about, have to divide it on the other side, which will leave us just then with x squared equals d over a. All right, now this may be a whole number, depending on what d is and what a is, or it may be a fraction. But once we've got it into this form right there of x squared equals d over a, and you can't even see everything I wrote, there we go. Then we're going to take the square root of both sides of that equation. So we would come in and we would go square root, all right? And then remember the answer will be both positive and negative on that side. So it's going to be plus or minus, x equals plus or minus some number, all right? So we're going to have both a positive and a negative. All right, so that's a lot of talking. Let's get in and let's look at some examples. So if you flip your notes over onto the second page here, we've got 4 examples that we're going to go through. So example A here says 3x squared minus 27 equals 0. So remember, the first thing we want to do is we want to get into the form of, and I'm going to write this here out to the side, ax squared equals d. Well, we can see that this is really like ax squared right here. The 3 is the a, the x squared is the x squared, and then this is like the d right here, all right? We need to get that across. So just like we normally would, because it is a negative 27, we are going to add 27 to both sides. So we're going to do the opposite. That's nothing new. You guys have been doing that for a while. So we subtract that across. We're left with 3x squared on the left side and positive 27 on the right side. Now, once we've done that, now we should go in and we should divide by a. So that's going to leave us with x squared equals d over a, whatever that is. So our a here was 3. So I'm going to divide by 3. So now I've got x squared equals 27 divided by 3 is 9. Well, once we're there, now our next step is we are going to take the square root of both sides, because whatever you do to one side, don't forget you have to do that to the other as well. So that means I'm going to come in and take the square root of x squared. Well, as we've talked about for a while, when you take the square root of a squared term, all you're left with is the thing that's being squared, which is x in this case, and then the square root of 9, all right? Now remember, there's going to be two versions. So there's going to be a positive and a negative version of this. And then the square root of 9 is 3, because 3 squared, or 3 times 3, is 9. So my final answer here is x equals plus or minus 3, positive or negative 3. All right, well, hopefully that gives you a gist of what we're really doing in this section when we're solving by square roots. So example B, much the same. We're going to go through that same process. I see that I've got a number here on the side. That's like a D, so I need to get it the x squared by itself. So I'm going to add 10. When I do that, I'm left with x squared on the left side equals negative 10 plus 10 is 0. All right, well, the number out in front of the x squared is a 1, so I don't really even need to divide by that. So I can skip right down to the next step, which is take the square root of both sides. Well, the square root of x squared, as we just learned, was x, right, equals the square root of 0. Now remember with this, when you take a square root of 0, all right, 0 is not positive or negative. So if you take the square root of it, it's not going to be positive or negative. It's a neutral. And the square root of 0 is just 0. Because 0 times 0, or 0 squared, is 0. So there's only one solution on B. Versus example A had two solutions. All right, so let's take a look at example C right here. I'm going to follow that same process, so I need to get the x squareds by itself. So first thing I'm going to do is I'm going to subtract 11 across. That's going to leave me with negative 5x squared equals 16 minus 11, which is 5. All right, now, all right, once I've got that, I need to get the x squared by itself. It's being multiplied by negative 5, so I'm going to divide by negative 5. So that cancels those out. I'm left with x squared on the left side equals 5 divided by negative 5 is negative 1. All right, and then I would go into my next step, which is to take the square root. All right, square root and square root. So square root of x squared is x equals, now something we need to think about is, can I ever multiply something times itself and come up with a negative number? Well, a negative times a negative. Well, let's just stay with negative 1. Negative 1 times negative 1 is positive 1. Positive 1 times positive 1 is positive 1. So you could never multiply something, right, by a negative number. Excuse me, you could never multiply something by itself and get a negative number. So there we go. Whenever that happens and you end up with this situation where you're trying to take the square root of a negative, you just say x equals no real solutions. You can never take the square root of a negative number. You'll learn about later on in math and algebra 2 about how we deal with square roots of negative numbers. We're not going into that here in algebra 1 because it gets a little bit more complicated. But the basis of it, even in algebra 2, is that there's not any real solutions to that. You cannot take the square root of a negative number. So whenever you end up with that situation, you just write x equals no real solutions. All right, so I'd encourage you now to pause it. Try example D on your own, then unpause it and see if you come up with the same thing that I do. All righty, well, I'm going to go through that step. First thing I need to do, get the 2x squared by itself. So I'm going to add 32, add 32. That leaves me with 2x squared on the left equals positive 32 on the right. Then I'm going to divide by 2, divide by 2. So I end up with x squared on the left equals 32 divided by 2 is 16. Now I need to take the square root of both sides, because whatever I do to one side, I have to do to the other in an equation. So I'm going to end up with x equals Does 16 have a perfect, or does it have a square root? Yes, it does. So it's going to be a plus or minus or positive or negative. And the square root of 16 is 4. So final answer equals x equals positive or negative 4. And that's all you're doing in this first section. So you've got all the tools you need. It's relatively simple. Just big things you got to remember is if you take the square root of 0, it's not positive or negative. It's just one answer, which is 0. Right? If you take the square root of a number that has a square root, there's both a positive and a negative version of that. So we need to have two answers, which is what we have here. And then if you try to take the square root of a negative number, just remember that's not possible. There are no real solutions. All right, that's everything you need. So jump on worksheet number 1. You're going to only have 2 days for the notes and the worksheet. We've been working in 3-day chunks, but now we're working in 2 days as we finish up this final chapter. They're pretty short, so if you need any additional support, please reach out to me. Give me a call, shoot me a text. We'll set up a Zoom meeting, send me an email, whatever. Get a hold of me. I'm happy to support you in any way possible. So have a great day, and we'll see you soon for the second part of the notes.